Welcome back, Math 8. Today we're going to talk about triangles one more time. So go ahead, grab something to write with, something to write on, and do your warm-up problem. All right, so the Pythagorean theorem is a squared plus b squared equals c squared. A and b are the legs, or the opposite and adjacent. Either one works. And then c is always that hypotenuse. All right. Our goal for today says I can use the Pythagorean theorem to determine if a triangle is a right triangle. So we're figuring out if it actually is a right triangle today. And our learner right responsibility is to take action on all feedback. So before we begin, I want you to determine if a triangle is a right triangle. How would we figure that out? Go ahead, pause the video and think about it for a moment. We are going to use that Pythagorean theorem, right? If we know that a squared plus b squared equals c squared, then any right triangle is going to fit into that equation. And if it doesn't fit, then it's not a right triangle. So that's what we're going to do today. So we're going to do both of these problems, but let's just look at the orange one first. We're going to determine if the following side lengths make a right triangle. And so, remember that we still need to keep that a squared plus b squared equals c squared. Right, that's our Pythagorean theorem, so that's what it needs to match to. And we're going to give each one of these one of its letter values. It's either going to be the A, the B, or the C. Now, what's super important to remember is that our C value is always going to be the largest number. The hypotenuse has to be the longest length. So automatically, if I look at 8, 15, and 17, 17 is the biggest number, so that's going to be my C. Automatically, it has to be. There's no other option. And then remember that A and B are transferable. It doesn't matter which order they go in. So I'm just going to say A, B, C. So I'm now going to set this up. I'm going to say 8 squared plus 15 squared equals 17 squared. Because that's my Pythagorean theorem. That's how it's set up. 8 times 8 is 64. Plus 15 times 15 is 225, equals 17 times 17 is 289. You're not required to have that one memorized, so I'm giving it to you. And now I need to combine my like terms. 64 plus 225 is 289. And does 289 equal 289? Yes, it does. So 8, 15, 17 is, in fact, a right triangle. It's not so bad, right? So let's try this other one now. 6 square root 190, 15. Now, if you remember, I said that the C value, our hypotenuse, has to be the biggest number. And I know that you see 190 and you automatically want to say that that's the biggest. But remember, we're taking the square root, so we're finding out what number multiplied by itself equals 190. And as it turns out, it's a number smaller than 15, because 15 times 15 is 225, which is bigger than 190. So 15 is actually the biggest number that we have in this list. So that's going to be my C value. And so again, my A and B are interchangeable, so I'm just going to put A here and B here because alphabet. And I'm going to say 6 squared plus the square root of 190 squared, not a plus, equals 15 squared. So now I'm going to do that. 6 times 6 is 36. The square root of 190 squared. If you guys remember way back in like September or August timeframe, when we were doing squares and square roots, I had said that they were inverse operations. They undid each other. So if I have a square and a square root that undo each other, both of them poof, and I'm just left with 190 equals 225. Because that's what 15 times 15 gives me. So now I need to add 36 plus 190 gives me 226. Does this equal 225? No, it does not. So 6 square root of 90 and 15 are not a right triangle. So I hope you can see the difference, right? This one, it equaled itself, so it worked. This one does not equal itself, so it does not work. Ooh. wrong direction. So now it's your turn. I'm going to have a bunch of problems here, and I want you to copy them down, pause the video as you need. I'm going to slowly scroll through them, and I want you to determine if their side lengths make them right triangles, just like we did on those two previous examples. There's quite a few problems, so pause as needed. That's the end of that list. All right, so we're back at that top of the list with our solutions. Some of them are worked out. Go ahead, check your solutions, pause the video as needed. Some of them, again, are worked out for you. And just so we're aware, I made it so that all of those very last numbers were the hypotenuse, just to make that a little bit easier. So make sure we are checking our solutions. The ones that are worked out, make sure that you have those solutions worked out nicely. All right, and hopefully you got those. So our closure for today, these were two problems that were determined to not be right triangles. How could you change them so that they are right triangles? Go ahead, think about it, pause the video, and until next time, I will see you later. Love you, bye.